Further Solutions Academy. Further Solutions Academy. Share our videos, share and subscribe. Please help us to share to your friends and subscribe to our channel. Once again, this is Further Solution Academy. In this video, I'll be walking you through, let me just pick up one of these, which is trigonometry. But let me explain some things here. In mathematics is very interesting. It's very, very nice. But what you need in mathematics is just the foundation. Before you can do fine in, is level by level. Those things are level by level. Now, I'm basically on advanced mathematics, trigonometry. I want to move on to, I think I'm on trigonometry now. Now, before you can do fine on integration, Laplace, ordinary differential equation, Fourier series, and so on and so forth, you must understand at least these topics. You have to understand them. You have to understand this topic very well. These are very important. The first one is trigonometry. The second one is the second one is polynomial and partial fraction, binomial theorem and what Pascal triangle, matrix, indices, logarithm, and sort. There are more of them, but these ones, they are very important. Most of them are in algebra, but this one is a trick. Now, can we move on? Let's start from trigonometry. I will try to explain one of them, explain and give some little examples, so that when we are in advanced maths, you won't have issue, you have problem. Okay, let's start with trigonometry today. Let's start with trigonometry. Now, I want to start with trigonometry. Now, this trigonometry is a one aspect of mathematics. It's a one applied aspect of mathematics. They are under shape. Now, if we are talking about we are talking about three angles, which involve three sides and sides. Three side and sides. Now, I have sides. This can be my size. This is my size. This is my side. These are my side. My side. This is size. And also size. And what? Side. Now, it involves three sides and three sides. Now, which that size is referring to what? Angles. Now, if we are moving on, there are three types of, they are all originated from triangle, and there are three types of triangle, which we all know that we have isosceles triangle. Now, one tells us that what? If it is isosceles triangle, none of the sides are equal. Now, none of the sides are equal. Now, we have scaling. This can be scaling. This is scaling triangle. The second one, we have isosceles triangle. That one is telling us that what? The two are equal. This angle, this B, this is A, this is C. Now, it means B equals to C. B equals to A. Why? If I have A centimeter here, B centimeter here, it means my B equals to A. Now, it means two angles and two sides are equal. Now, the last one is called equilateral triangle. Equilateral triangle. It means the sides and the side are equal. Everything are what? Equal. The side and the sides are equal. And also, there are the angle on the triangle is 180. The angle on the triangle is what? 180 degrees. Now, some of any given triangle is 180 degrees. Now, okay, there are three types of angles also. There are three types of angle. Now, the first one is known as what? Acute angle. Now, my acute angle is always less than what? 90. Now, it's less than 90. The next one is what? Obtuse angle. My obtuse angle is always greater than what? 90. Obtuse is always greater than 90. While the last one is known as what? Reflex angle, which is what? Always greater than what? 180. Reflex angle. These are the three types of angle. The first one is acute, obtuse, and what? Reflex angle. Now, all these things are very important when it comes to trigonometry. Now, also, angle operates at a point is known as what? 360. 360. Now, because this point has the same characteristics of what? Of circle, but it's very small. Very, very, very small. It has radius, it has a diameter, it has arc, it has a segment, and so on and so forth. Everything that you are talking about in circle also here, which it can be enlarged. You can also enlarge it. Now, angle on the point is what? Is 360. Now, I'm not on that side. I'm not in geometry today, but I want to work on trigonometry. Let me go far away from that. Now, let me start from, we have equilateral triangle. That equilateral triangle, it means the angles are equal. The angles are equal. Everything is equal, 60, 60, and 60. The angles are also equal. Ones are 60, sorry. This one will be what? Centimeter, decimeter. Now, if I cut it to 2, if I cut this angle into 2, I will have what is called right angle triangle. Now, I want to use my right angle triangle to perform some operation under trigonometry, which is known as what? Trigonometry ratio. I want to use this to perform some operation on it, and which is known as what? Trigonometry ratio. Now, before we continue, when you talk about isosceles triangle, you can use your sine rule, cosine rule. We have sine rule, we have cosine rule. Sine rule and what? Cosine rule to perform any operation here. Now, and also you can bisect into 2. Likewise, equilateral triangle. But scaling. The scaling aspect of it, none of the sides are equal. None of the sides are equal. It means what? If you want to perform any operation on it, you must use your what? What's it? Sine rule and what? Cosine rule. I'm not yet for that. I may not be able to go far in that area today. Now, let me start from equilateral triangle. With equilateral triangle, I can have what? I can have trigonometry ratio. Now, one part of my equilateral triangle form my what? Right angle triangle. One part of it. This is what? My function of x and what? Of y. Now, if I can form my theta here, I can form my theta here. If I should form my theta here, which is my angle operating on. Now, it means my opposite will be here. My adjacent will be here. And my hypotenuse will be here. Now, hypotenuse is always constant because it is the longest side of the triangle, which is longest side of the right angle triangle is known as what? Hypotenuse side. Now, but their distance, which is centimeter, wherever. Now, opposite is always facing the what? The angle. Where it faces the angle is known as what? As opposite. Now, while the other side is what? Adjacent. Now, we cannot bring up what is called what? So-ka-twa. By so-ka-twa. Now, this aspect is very important in mathematics, in advanced mathematics. This so-ka-twa. Now, we have sine, we have cos, we have tan. We have sine, we have cos, we have tan. My sine, okay, my sine, okay, let me use sine theta. It always equals to O all over H. Why my cos my cos theta is it always equals to what? A all over what? H, sorry, this is H. And the last one is what? Tan. It's always equals to what? O all over A. Now, my A is standing for what? O is standing for opposites. My H is standing for what? Hypotenuse. A is standing for adjacent, while H is standing for what? Hypotenuse. O is standing for opposite, and what is standing for what? Adjacent. That is all about what? Trigonometry ratio. Now, they have all of them, both of them has the reciprocal. They have reciprocal. Now, the first one is if I have sine inverse, my sine inverse of theta, it will be equals to what? 1 all over what? Sine theta, which is equals to what? It will be equals to cosec theta. Now, if I have cos inverse of theta, it will be 1 all over what? Cos theta, which is equals to what? Sec theta. Now, if I have tan inverse of theta, it will be equals to 1 all over tan theta, which is equals to what? Cot theta. Now, these are very, very important. Now, inverse of each of them produce all this. Now, can we move on? The next one is, I want you to understand is, okay, we can now say that what? A bit of, let me go a bit of, okay, let me move on to special angles. Special angles, they are very, very important in mathematics. What are the special angles? They are angles that can be expressed in a solid form. They are angles that can be expressed in a solid form. Now, please note that if I have 1 all over root 3, this is not proper. It's in a solid form. Now, you have to rationalize it by what? Root of 3 all over root of 3. Now, I think I can say a root of 3 all over 3 is proper now. Your surge must not be in position of what? Denominator. When you are solving, when you give out any answer to anybody. Now, your answer must not be in form of what? The surge must not be in position of what? Denominator. Now, if you are talking about special angle, normally, we have two ways of proving them. The first one you can use, there are first quadrant. We have quadrant, I think, let me pen out the quadrant. The first aspect of it, which I want to work on this particular angle 90 now. This special on them is 0 degree. These are theta. Now, 0 degree, 0 degree, 30 degree, 45 degree, 60 degree, 60 degree. Sorry, let me just put it down here. 60 degree and 90 degree. Now, these are first special angles. These angles there that can be expressed in a ratio form, 0 and 90. They are very unique. You can generate them 0, 90, 45. You can generate them from what? Okay, 45 and 90, you can use your what? Square to generate it. Square can generate that, because 90, 90, when you cut off the diagonal of that 90, I think I can have 45 like this. I can have 45, and by so doing that, you use your what? So casual. Now, I'm not here to do all those things, but if you are you have this type of special angles, how will I go? I can use something like this. Okay, I have 0, 1, 2, 3, 4. Now, the first number that have square root, except 0 and 1, is 4. Now, I will now move on 4, 4, 4, 4, 4. Can I square root all? 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 And all. Now, if I should work on sine theta now. My sine theta, now if I should work on sine theta, it means this is equals to what? Is 0. This is 1 all over 2. This is what? Root 3, root 2 all over 3, and this is root 3 all over 2, and this is what? 1. That is my what? My sine 0 is what? Is 0. My cos, that means sine 60 is what? Half. Sine 30 is half. 45 is root 2 all over 2. Sorry, root 2 all over 2. Now, of 60 is what? Root 3 all over 2. And this is what? 1. That is my sine 90 is 1. The same thing on cos. If I should talk about cos, sine theta is always equals to what? Cos 90 minus what? Minus theta. It means when sine is moving forward, cos will be what? Moving backward. Now, for instance, if I have sine 60 now, for instance, it will be what? Cos 90 minus what? 60. It means sine 60 is same as what? Cos 30. You can use your any calculator to check that they are all equal. Now, since then, I can see that what? My cos theta can be what? Now, the angle will change this time around. The angle will change this time around. What are the angle? It means 90 will be here, 40 will be here, 60 will be here, 45 will be here, 30 will be here, and 0. It means cos 90 is 0, cos 60 is half, cos 45 is root 2 all over 2, cos 30 is root 3 all over 2, and over this is what? Is 0. Cos 0 is 1. Now, that is how it is. Now, that is how cos 0 is what? Is 1. Now, that is all, is that this can help us in special angles of sine and what? Sine and what? Cos. Now, let's move on to tan. Now, if we are talking about our tan, I want to use this thing. I won't like to. Now, if I'm talking about my tan theta is a mixture of sine and cos, which is always, I will show that later, which is all over cos theta. It is very, very, this is how my tan is. How do I still do that? If I have XL, and if I'm talking about what? My tan, okay, sine theta, it will be what? This is 1. Now, my sine theta, it will be what? Y all over 1, which is y equals to what? Sine theta. Now, cos theta, it will be what? Adjacent x all over 1, which is my x equals to cos theta. Now, if I now talk about tan theta, it will be what? Opposite all over adjacent x, which is equals to, what is my opposite? My opposite, which is what? My opposite, my tan theta can also implies what? My y is what? Sin theta all about cos theta. That is all about that. Now, it means my tan is always equal to this. Now, if I should work on their special angles now, I have theta. Now, is 0. I have 30. I have 45. I have 60. I have 90. Now, they are all in degrees. Now, if I should do this, it means my tan, I'm working on my tan. Now, my tan is 0, 1, 2, 3, 4. Now, the sign, this one is standing for what? Sine. This line is standing for what? This row is standing for what? For sine. Now, the next one that will be standing for cos, it will be what? It's a reversal of each other, which is 4, 3, 2, 1, 0. This one will be standing for what? Cos. Now, if I should root all, now it means my tan theta, this one will be what? 0, 1 all over root 3, which is not proper. you should do it and rationalize with what I've said that time, which when you rationalize it, 1 all over root 3 times 1 root 3 all over root 3, which I have root 3 all over what 3. Now, I think that is what's supposed to be here, but to explain that math. Now, this is 1. 2 all over 2 is equals to what? 1. Root of 1 is what? 1. This is root 3, and this is what? Undefined. I mean, undefined. Now, now, this is all on what? On time. It means when you are talking about time, it's always terminate. When we get there, you will really understand. Okay, that is all about on special angles. Now, before we move on again and again, let me try to illustrate another aspect which is called quadrant. Quadrant is another aspect of trigonometry that is very, very important. All this information are very, very important. All this information are very, very important. If I'm talking about quadrant is a very, very, very important aspect of what? Of mathematics. Now, if I have quadrant, this is how it always look like. This is all, this is sine, this is cos, and this is tan. It's very, very, this is tan, sorry. This is cos. Now, it means all are positive here. All are positive. Only sine is positive. Only sine is positive. Others are what? Negative. And tan are negative. Only this is positive here, and others are what? Are negative. Sine and cos. Now, only cos is positive here. Others are what? Are negative. Are negative. Now, okay, that is for first number 1. Number 2, this movement is on what? Anti-clockwise, which all is positive. Here explain 90. Now, it means if I should work on my angle here is 90 minus theta. It's very important. Also, here is what? 180 minus theta. Now, this one, theta minus 180, and this one is 360 minus what? Minus theta. Now, first quadrant, second quadrant, this is first, this is second, this is third, and this is fourth. Now, that's how it is. Now, let me just show some things there. If I have something like this, for instance, I have something like this. I have something like this. Now, if I should work on, this is what? Always my R. It's always my R. Now, angle can form there, angle can form there. This is what? Of my X. This is of my Y. Now, if we are talking about what? For instance, theta here. Sin theta here is always equals to what? Sin theta is always equals to what? Sin theta is equals to y all over r. Cos theta is equals to y all over r. Tan theta is equals to what? Y all over x. Now everything there is positive. But if you come here, here, you can see that this is, go to your graph. This is a negative x, positive y, negative y. It's very, very important. That is the logic behind this. Now, also, if I should have this, this is negative x. It means wherever that is operating here, it will be minus x. Now, y others are what? This is y, and this is your r. The same thing, if angle forms there, I can say that what? If angle forms there, I can say that what? My sin theta, it will be equals to y all over r. Cos theta, it will be equals to minus x all over r. And tan theta, it will be equals to what? Y all over minus x. That is why. Okay, and also, if I should have this, my, if I should have this, I should have something like this. This is my minus x. I can also do something like this. This is my what? Minus y minus x. The same thing. If angle forms here, anyway the angle forms. No, okay. I sine theta, it will be equals to what? Minus x all over what? R. And cos theta, it will be equals to minus y all over r. But if I should talk about tan theta, it will be equals to what? Minus x all over r. I mean minus x. Okay, minus x all over, which is what? I have what? Okay, let my angle forms here. Anyhow, let my angle forms. Okay, no, anyhow, it's not okay. It's okay. Now, which I have, minus we cancel, only tan is what? Positive. Others are negative. The same thing that happened here. Cos will be negative here. Now, that is all about on what? Quadrant. Now, let's move on to, now, okay, let me try to explain complementary angle and complementary angle is very, very important to understand that complementary angle. Now, if we are talking about complementary angle, my complementary angle is always equal to my complementary angle. Now, my complementary angle. Now, if I'm talking about my complementary angle, if I have, just note that if I have cos theta, for instance, it would also the same thing as what? B all over C, which is can be also equals to what? Sine 90 minus theta. I think I've explained this. Now, it means they are complementary. Now, that is what? Complementary. For instance, if I have tan theta, there are proof for them. I can also express my tan theta as A all over what? All over A all over B, which same thing as what? The same thing as cot 90 minus theta. Okay. Sine, tan and cot and cos and, okay, that is what I want to explain, that and that and that. For instance, if something like this is given to us, okay, something like this is given to us, if sine x minus alpha equals to cos x plus alpha, cos x plus alpha. Okay, we want to look for what? Find x. We want to find x or find tan theta, tan alpha, or x. Find tan alpha. That our alpha is what? Is angle. Now, how will I do? I can go by having something like this. Since sine x is equals to what? Cos here. Okay, I have, since sine theta is equals to what? Cos 90 minus x. Same thing. Okay, since this is equals to this, okay, therefore, I'm just using my x as my angle. Okay, if I should express that, I can also say that what? This, I can now express this. Sine x minus alpha can be equals to sine 90 minus x plus alpha. This is big bracket. Now, I can have something like this. Since I have this, I have no problem again, which I will have sine and sine. They can move out of the way. I have alpha equals to what? 90 minus x minus alpha, which they have cut off themselves. Now at this point, x and x. Okay, what can I do next? What can I do? I can say that what something can cut off there. If I should collect like times, now what will happen is that alpha will cancel alpha, alpha will cancel, this is 90. Now alpha will cancel alpha. Since alpha has cancelled alpha, okay, now alpha has cancelled alpha. Now it means I can say that what my x plus x equals to 90, which is my x 2x equals to what? 90. My 2x equals to 90. My x equals to 45. My x equals to 45 if we divide both sides by what? By 2. Now my x is equals to 45. Since my x is equals to 45, I can answer that what? My x is equals to 45. If I should look for tan x, my tan 45 is equals to 1. I think that is my answer. That is all about that. Now, let's talk about trigonometry identity. Trigonometry identity. Okay, I would like to stop here for now under trigonometry, because trigonometry is very wide. I'm just to brief the class. I just want to brief or to explain some very important aspect of trigonometry. Trigonometry is a very wide aspect of mathematics. Once again, this is Further Solutions Academy. We have to stop here. We'll be expecting part 2 of trigonometry. This is Further Solutions Academy. Further Solutions Academy. Subscribe and share our video. Just do us a favor by subscribing and share to people so that it will encourage us of doing more. Thanks for watching.